Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code P0563, which pertains to the ECM or PCM power source circuit in the 2006 to 2011 Honda Civic. The ECM stands for Engine Control Module, and the PCM refers to the Powertrain Control Module, both crucial components for vehicle performance. A logged DTC indicates an unexpected voltage issue, compromising the reliability of the signals these modules receive. Understanding the implications of this code allows technicians to systematically identify and rectify the underlying problems, ensuring optimal vehicle operation. Thoroughly documenting all freeze data and onboard snapshots before starting diagnostics allows for better insight into intermittent issues. This approach ensures a well-informed troubleshooting process that adheres to the vehicle's operational requirements. The DTC P0563 indicates that there is an unexpected voltage in the ECM or PCM power source circuit. The Engine Control Module, ECM, plays a critical role in controlling engine functions, while the Powertrain Control Module, PCM, manages not just the engine, but also transmission functions. Both these units depend on consistent voltage to operate efficiently. Specifically, in the Honda Civic, these modules are typically located in the engine compartment and interact with various sensors and actuators to manage vehicle performance. Anomalies in voltage can disrupt these communications and lead to performance issues. Identifying the correct circuit and connections is crucial in diagnosing this trouble code effectively. There are several causes for the DTC P0563. The first being poor electrical connections, which may result from corrosion, dirt, or loose terminals. Such issues can prevent proper voltage transmission and affect the vehicle's operation. The second potential cause is a defective PGM-FI main relay, which is responsible for supplying power to the fuel injection system and various engine functions. If this relay fails, it could lead to insufficient or unstable voltage to the ECM or PCM. The third cause might be a faulty ECM or PCM itself, which would require deeper diagnostics, as this could indicate an internal failure within these critical components. Each cause must be thoroughly investigated to pinpoint the issue accurately. Symptoms associated with DTC P0563 can significantly affect vehicle performance. One common symptom is engine stalling, where the vehicle may suddenly shut off or run poorly, leading to hazardous conditions. Drivers may also experience a noticeable increase in fuel consumption due to irregular engine operations, as the ECM or PCM struggles to correct performance issues. Furthermore, the check engine light, CEL, is typically illuminated when DTCs are logged, alerting the driver to potential problems needing immediate attention. Recognizing these symptoms can help in promptly addressing the underlying electrical issues, ultimately preserving the vehicle's longevity and efficiency. The first step in troubleshooting DTC P0563 involves turning the ignition switch to the on-to position. This action powers up the vehicle's electronics, allowing the technician to gather critical information. Additionally, it's essential to record any freeze data at this stage. Freeze data provides a snapshot of various sensor readings right before a fault occurred, making it invaluable for diagnostics. Furthermore, reviewing the general troubleshooting information helps familiarize the technician with potential issues related to the error code. This initial preparation sets the stage for a systematic and effective troubleshooting process. In this step, the technician must clear the log DTC using the HDS, which stands for Honda Diagnostic System. The HDS is a specialized tool that taps into the vehicle's computer systems to manage diagnostics efficiently. By clearing the trouble codes, any confirmed issues can be extracted afresh when the vehicle is put back into service. This clearing process also resets the vehicle's monitors, allowing a re-evaluation of the power source circuit voltage. It prepares the technician for a better understanding of the current state of the system prior to conducting further checks. After clearing the DTC, the next step is to turn the ignition switch to the lock 0 position and wait for 10 seconds. This short waiting period allows the vehicle systems to stabilize and ensures that any residual voltage is dissipated. Following this reset routine is critical, as it facilitates a proper establishment of communication between the vehicle's electrical systems and the engine control unit. This step helps to prepare for the subsequent checks that will confirm whether the DTC is an intermittent failure or if it persists, necessitating further diagnosis. With the ignition switch back in the on position, the technician should now use the HDS to check for any pending or confirmed DTCs. This step is crucial for identifying if DTC P0563 has reappeared after the clearing process. By properly monitoring the data through the HDS, the technician can ascertain if the power source circuit is functioning as intended or if underlying issues persist. If DTC P0563 is indicated once again, the technician will proceed to the next step. If it does not, then the issue is likely intermittent and may be due to loose connections or poor wiring. If DTC P0563 continues to register, the next troubleshooting step requires toning the ignition switch back to the lock 0 position. The technician will then jump the SCS line using the HDS, a method employed to discharge some vehicle systems and prepare for diagnostics. This step helps isolate the ECM or PCM from other circuits momentarily, which is necessary for making precise measurements. Adjusting the HDS settings or connections may also be necessary at this stage, ensuring a consistent diagnostic approach for testing the electronic systems associated with the power source. After successfully jumping the SCS line, the technician will proceed to disconnect ECM-PCM connector A, which is often a multi-pin connector located within the engine compartment. Following this disconnection, the technician must measure the voltage between ECM-PCM connector terminal A6 and body ground. This measurement is critical, as it directly assesses whether the terminal is receiving adequate battery voltage. A properly functioning voltage level should reflect battery voltage. Otherwise, the technician must proceed to further diagnostics or repairs. This step ensures accurate readings required for identifying any deficiencies in the power source circuit. Once the technician measures the voltage, the next step is to determine if battery voltage is present at terminal A6. A yes response means that the power source circuit is functioning correctly and suggests that the technician should skip to step 13 for further evaluation. However, if the voltage is found to be absent, this indicates a more significant issue within the circuit, prompting the technician to proceed to step 11 for further investigation. Understanding the voltage status at terminal A6 is crucial. It acts as a primary indicator of whether the problem lies within the ECM/PCM or is due to a faulty connection or relay in the system. If terminal A6 does not show battery voltage, the next step is to remove PGM-FI main relay 1 from the underhood fuse relay box. This relay plays a pivotal role in managing power to various engine systems. Once the relay is removed, the technician needs to check for continuity between ECM-PCM connector terminal A6 and body ground, ensuring there are no interruptions in the wiring or connections. This step reveals potential connectivity issues, which could lead to unexpected voltage readings. An open circuit or absence of continuity suggests that there may be a problem with the relay, wiring, or connection points that need further attention. After troubleshooting and conducting necessary repairs, A final verification process is essential to ensure that the vehicle is functioning correctly. The technician should meticulously recheck all electrical connections and wiring leading to and from the ECM and PGM-FI relay, confirming that voltage levels at terminal A6 meet required specifications is critical. Discrepancies might indicate that previous repairs didn't fully resolve the issue. Lastly, conducting a complete scan for DTC reappearance provides reassurance that the problem is rectified. This thorough conclusion step helps maintain the integrity of the vehicle's electrical systems, ensuring reliable performance. Preventive maintenance can significantly reduce the likelihood of encountering DTC P0563 in the future. Regularly inspecting wiring for wear, oxidation, or frayed connections helps catch issues before they lead to voltages dropping unexpectedly. Ensuring the functionality of relays, like the PGM-FI, should be part of routine maintenance as well. A failing relay can disrupt power delivery to critical systems. Moreover, keeping connectors, including those associated with the ECM and PCM, clean and free from corrosion, aids in preventing voltage anomalies. Implementing these preventive measures contributes to the longevity and reliability of the Honda Civic's performance over time. In summary, understanding the implications of DTC P0563 is vital for maintaining the reliability and performance of the 2006 to 2011 Honda Civic. Following the systematic troubleshooting steps helps identify and rectify the voltage issues affecting the ECM and PCM power source circuit. Moreover, implementing preventive maintenance strategies can significantly reduce the risk of reoccurrence by ensuring that all electrical components remain in optimal working condition. The process not only resolves immediate concerns associated with the DTC, but also contributes to enhanced vehicle performance and longevity. Ultimately, thorough diagnostics and timely repairs ensure the continued reliability of automotive systems. Please like and subscribe to the channel. See you next time.